Okay. Well, hope everybody's having a good day. Just a few reminders. Friday is the end of the 6 weeks, so you have a few days left. If you want to retake last couple of assessments we've had, referring to the correlation coefficient quiz from last week or the exam from last week, the second exam. So if you want to come in, ask some questions before you go ahead and take it, we still have until Thursday morning by 8:05. I'm looking towards the end of this week on Friday. We'll have ourselves a little exit ticket over the chi-squared, get a little more practice on that. In fact, the exit ticket is a released question from one of the paper exams this past May. So again, kind of give you an idea of how that could show up on the exam. And then hopefully starting tomorrow, with any luck, we will go ahead and start our next unit, and we will just continue as far as we can. Any questions? All right. Okay, so did everybody have the opportunity to turn in your chi-squared assignment? Okay, so turning it in today gets you the first points in that point bank I mentioned yesterday. So were there any questions on chi-squared? Hey.
So with the points that, the point
It'll be this 6 weeks. Yeah, I'm always going to do it within the same 6 weeks period. Okay. So no questions on chi-squared. Do we want to run through the calculator keystrokes to make sure we remember that?
Yeah.
Yes? Okay. Then let's go ahead and choose just one right here. Looks like my categories are being diabetic and non-diabetic versus weight. Okay. So, in fact, I believe I have this right here, so I don't have to keep clicking back and forth. Okay. All right, so the first thing I need to do is go ahead and put in my observed data from the contingency table into the calculator. All right, so this is one of those times I don't need the lists and spreadsheets, but I will go ahead and use my scratch pad. Where do I go? Okay, so we need to put in a matrix. Where do I find that, Joey? Okay, between 9 and the catalog here, so this button. Okay. The dimensions of this contingency table are a 2x3, so I'm going to use this template here. Okay. All right. So it looks like I have 11, 19, and 26. And we have 79, 68, and what is that? 69. Okay. All right. So I've got the data in. Now what? Okay. Go to what? Control variable, there we go. We're going to go ahead and label it. Again, X is what I usually prefer, but you can do anything you want. Okay. So now I go to menu because I've got the data input, statistics, stat tests. We want the two-way contingency table, not GOF. That's goodness of fit. That is another test. Okay, what matrix would you like? Well, X that I just plugged in, and there we go. Okay, so this one here looks like my chi-squared value is about a 6.61. There's my p-value, which could potentially be very useful. What's DF? Okay, degrees of freedom. If I wanted to see the expected frequency matrix, I could go ahead and just click the variable button right here, EXP matrix, enter. How do I calculate those values? Like this 18.5294. If I go back over here, okay, how did I calculate that for diabetics with lightweight? There's something I multiply. Okay, Laura's right. I multiply the total of that column times the total of that row, and then I divide it by what? Okay, the total number of people involved in the survey. All right, which would always be in the bottom right corner. They're just not filled in here. Okay, good, good, good. And in fact, let's go ahead and see. We know that the degree of freedom here is going to be 2. Does everybody remember how we calculate that? Okay, number of rows minus 1 times the number of columns minus 1. And I believe the problem was talking about 5%. Significance level. So let's do this. Let's come on over here. Okay, I believe this was this page right here, number 9. Okay, so we have degrees of freedom of 2, and we're going to do it at 5%. So that critical value is 5.99. So let's do a comparison very quickly. Okay, 5.99 is my critical value. Oops, that's not what I needed. Okay, so 5.99. We got a critical, calculated value. I believe it was 6.61. So our calculated value is larger than the critical value. Okay. And maybe you have it in your notes. I do have it on the backboard again. But what does it mean if our calculated value is greater than the critical? Okay. We reject the null hypothesis. In fact, what does the null hypothesis always say? That the two are independent. There is no association. There's no relationship. And I mean, in this one, it kind of makes sense because could your weight affect whether you do or do not have diabetes? Absolutely. Okay, so that kind of makes sense. All right. And then the p-value is just another way of confirming or possibly even contradicting the answer that you just got. Okay.
How did you get the expected values on the calculator? Again, I don't think I was here for that.
Okay. So when you pull up all the information here, what you go ahead and do, and I can just do this again. Okay. You're just going to hit the variable button without hitting control this time. So I'm going to hit that, and then I want EXP matrix, the expected matrix. Okay. And then I'll just push enter, and it'll go ahead and give me all those. Okay. All right. Questions? Okay. Now remember, if you're turning in the chi-squared homework today, then you will be able to get the points in the point bank, even if it's by the end of school. As long as I get it before I leave, I've never been a big stickler about that. Okay, but if you get it to me tomorrow, I mean, that's still great. Probably give you a high five, but you won't get the points. Okay. But Jacob, what would you rather have, points or a high five?
No, it depends on the day.
Depends on the day. Always a high five. Exactly. There you go. All right. So good. Document B. All right. Well, let me go ahead and move past this. If you do have any other questions about, chi-squared, let me know. Now, this next section, this is going to be specifically on limitations of the chi-squared test. And we should be able to wrap this up today. There's not a whole lot, but I do want to make you aware of some things. If you are planning on using the chi-squared test for independence on your internal assessment, you do need to be aware of some of these ideas. There are 2 situations in which the chi-squared test may be unreliable. The first, any of the expected frequencies are less than 5. And I didn't answer the question at the time, but I think it was a little over a week ago, John Henry asked, why does that make a difference? Well, if you start to notice that some of your expected values are less than 5, as in this example that we're going to take a look at, well, it can mean possibly a couple things. Maybe one, that your sample size isn't large enough. Okay, so the number of people that you took data on, maybe you want to go ahead and collect some more, increase your sample size, or it could just be that possibly you have too many subcategories. Okay, and you'll see what I mean when I say in just a second. But there are a couple of reasons why that happens. Now, we solve that problem by simply combining data. Okay, 2, the degrees of freedom is 1. Okay, so really, if you're dealing with an observed contingency table that has 2 rows by 2 columns, you'll want to go ahead and use this modified version of the formula. Okay, so you won't be able to do it in the calculator. You'll have to calculate it by hand, which is something you were going to have to do anyway on your internal assessment. Okay, so let's take a look at an example. All right. So if we have any expected frequency values less than 5, so consider this one. We're comparing gender to watching TV. So my categories here are rarely, sometimes, often, or very often. Okay, well, all the information is right here over at the left, but what we're interested in are the expected frequency values. So if you go ahead and start comparing these, you'll notice there's a problem in the very often column for both males and females. Okay, 4.05 and 4.95, even though that's really close. Now, there is one exception to this, and I mentioned it briefly the other day. If the number of cells in your table, okay, that are 5 or less, if that represents 20% or less of your cells, you're still okay. You don't have to worry about that. Okay, but if it's anything over 20%, then you're probably going to want to go back and try to fix it, probably by combining data. Okay, so in this case here, we have 1, 2, 3, 4, 5, 6, 7, 8 cells. 2 of them are less than 5. So what percentage is that? 2 out of 8. So it's 25%. So if it's over 25%, your results may not be reliable. If it's less than 20%, you're probably going to be okay. But maybe it's something that you would want to go ahead and mention if it applies to you in your internal assessment. So you'll notice one of the reasons this could be happening is when you're comparing your quantities, you might have too many subcategories, as I called them. Well, do you notice anything about your columns here? You have rarely, sometimes, often, and very often. Okay. Does anything kind of stand out to you? Did any of those columns seem just like they would be very closely related? Okay. I mean, what would really be the difference between what we're considering often and very often? Okay. In fact, you'll notice depending on what column or rows your values of less than 5 are in, that would help you determine, well, do I need to go ahead and combine certain columns or do I need to go ahead and combine certain rows? Here, I'd make the argument because often and very often are really very close to each other. I mean, they're almost essentially the same idea. You just go ahead and combine those 2 columns, which is what it shows, okay, right here. Okay, so you'll see I just went ahead and combined them into often and very often. So now I've got a 2 by 3, but take a look at what happens when I go ahead and find the expected frequency values for that new table. You'll notice none of them are what? None of those expected values are less than 5. Okay. All right, so it's an easy fix. It's either columns or rows that you could combine. Okay, or you could simply go ahead and increase your sample size, gather more data. Okay, we don't have an example of that. Here my examples are combining rows and or columns. So let's try this one. Okay, consider the contingency table alongside. Construct the expected frequency table. Okay, so I've got this 4 by 2 matrix here. So it looks like we have the age of an individual and whether or not they own a pet. Okay. So let me go ahead and wipe my calculator clear. Okay, which it already is. So let's go ahead and put in the data. Oop, forgot to go ahead and put in my matrix. Sorry about that. Escape. Got a little too far ahead of myself. So this was 4 by 2. Okay, 4 by 2. Okay. All right, so let's put in the values that I see here. So we have 5, 3, then we have 32, 22, then we have 42, 58, and finally 39, 34. Okay, so just like we did a moment ago, I'm going to go ahead, store this. Okay, again is X. All right, menu. What were the steps again? Statistics, stat tests, two-way test. Okay, we want that for matrix X. And here we go. So it looks like my chi-squared calculated value is 5.25, but I'm interested in the expected frequency values. Okay, so Emmy, how did I bring that up again?
Go to variable.
Go to variable. EXP matrix. There we go. And then click enter. Okay. Now, do we notice anything? Okay, there we go. Well, again, we've got 8 cells, 2 of which are less than 5. And even if you get really close to 5, you don't want them less than 5. It could mean one of those 2 things we talked about. So here, this one's going to be a little different. You'll notice when we were looking at this first example over here, it was the column that contained both values that were less than 5, right? So we solved that problem by combining those 2 columns. Well, here, it's not the same column that contains the values, it's the same row. So this would indicate to me a really good fix for this. I'd go ahead and combine the rows. Okay, so if I'm looking back over here at my paper, okay, because this one here, the 5 and the 3, gave me expected values that were less than 5, I would probably go ahead and combine that row with what else? There you go, the row right next to it. All right. So I would go ahead and say this first one here would go from 0 to 29. Then I would have 30 to 49. And then I would have 50 plus. Okay. So these bottom values are going to be the same. This one is 39. This one is 34. This one is still 42. This one is still 58. But now this top left one is 37. See, I went ahead and combined those rows. So what would this one be right here? 25. There we go. And that's the yes, and that's the no. Okay. So now let's go ahead and plug that data in, and let's see if that fixed the problem if we have any expected frequency values less than 5 still. Okay. So let's see here. Come on back over. Document B. Okay, matrix. So now we have a 3 by 2. Okay. Okay, and what were my numbers here? It was 37, 25. Then we have the same values, 42, 58, and 39, 34. Okay, let's store this. Control variable X. Okay. Menu, stats, stat tests, two-way test. Okay. All right. So now let's pull up the expected values. Okay. And you'll notice now every expected value is well over what? Well over 5. Okay, so it's an easy fix. Now, if you do go ahead and combine some rows or you combine some columns to eliminate a category, a subcategory that is, and it still doesn't work, what's another method that you could use? What was another reason I said this might be happening? Get more data. Go ahead and increase your sample size. There you go. Okay, so that's one possible limitation. In fact, is anybody collected data and you're going to be using a two-way table? Okay. Have you already run into this problem, or is yours okay so far?
I haven't been able to collect enough data yet.
Okay. All righty. Okay. All right. Well, any questions on that? Okay. All right. Well, that's easy enough. Okay. And then we have some other problems. I'm going to go ahead and just move on. Unless anybody just wants to work another problem to show you the expected frequency values less than 5. And I see a lot of people shaking their head no. So, okay. Bless you. If you do want to know, let me know. Okay. So the Yates continuity correction. Okay. So the chi-square test may also be unreliable if the number of degrees of freedom is 1. So either, if your data you're collecting, if you do go ahead and put it in a two-way table, you can go ahead and just, accept that this is the new formula that you should use, or you just collect enough data where maybe you could expand your table, like maybe a 2 by 3, 3 by 2, whatever the case is, as long as the degrees of freedom are not 1 any longer. Okay, so if the degree of freedom is equal to 1, we use this. So what's the difference between this and the original chi-squared formula we had? Okay, there's one extra little item here. We're subtracting what? We're subtracting 0.5. Okay, from each of those differences, the absolute value, and then we're squaring that quantity. All right, so let's just do an example. Let's do this number 1 right here. Okay, so we have our quantities are guessing the outcome of a flipped coin versus the result. Okay, so we have a 2 by 2 contingency table, heads and tails. Horace claims that he can predict the outcome of a coin toss. To test this, he tosses a coin 200 times and tries to guess the outcome of each toss. Okay, I mean, I hope by the end of this, 200 times he changed somebody's mind. It's a coin changed his mind. Moving on. The results are shown alongside. Construct the expected frequency table. Okay. So what I'm going to do, go to matrix. Now this one's a 2 by 2, so I can just go ahead and choose this template right here. And I've got this paper in front of me where I've got 54, 50. Then I've got 41 and 55. Okay. And let's go ahead and store this like we always do. And, let's get crazy. Y. Okay, there we go. Just going to get insane today. Why not? There we go. All right, so we're using Y now. Menu. Run me through the steps again. Statistics. Stat tests. Two-way test. And this time I put in Y. Okay. All right. But now, what we're really interested in are going to be what? Okay. Well, let's go ahead and do this. Let's go ahead and say that there's no issue here, right? So what would you say my chi-squared calculated value is? 1.699, so 1.70 if we wanted to say 3 sig figs. Okay, so let's say 1.70, and it does tell me 5%. So it goes ahead and gives me the critical value. We don't have to look it up in the table. So I have 1.69. Okay, so let me come back over here. The data as it stands right now, okay, we've got 1.69, well, I said 1.70, 1.70, and we're comparing that to a 3.84. All right. Remember, you need the significance level and your degrees of freedom in order to find that number. Well, you'll notice our calculated value is less than 3.84. So what's this telling me? Okay, what's that, Ella? They're independent. Okay, we do not reject HO. So right now there's no relationship between the two, right? Okay, but there is an issue here. Remember, the degrees of freedom is equal to 1. So what we want to do, we're not going to go ahead and do the normal test that we've applied before. Let's go ahead and do this by hand, but using this new formula. Okay, this guy right here. All right, so you'll notice the very first time I ever showed you chi-squared on a table, we went ahead, had the observed values, the expected, then we took the difference, then we squared them, then we divided by the expected. Well, I did the same thing here, just progressing to the formula that we need for the Yates continuity correction. Remember, you only have to use this formula if what? If the degrees of freedom is 1. This does not apply if you have any expected frequency values less than 5. Okay, so let me go ahead and plug in the numbers I got here. So the observed data, I had 54, 50, then we have 41 and 55. Okay, coming straight from the table. Okay, well, can anybody go ahead and tell me the expected frequency value that matches up with the 54? Okay, 49.4. That's exactly what I got. Thank you, sir. Okay, 49.4. And then what about 50? Okay, so we're looking for the expected frequency value for the guess being heads and the result being tails. So that corresponds to this 50 right here. Who can help me out? I got 54.6. Good job. Okay. And who can help me out with 41? 45.6. And we'll finish up with 55. 50.4. There we go. Okay. So now we progress through the little items we would need for the whole formula. So we need to take the difference of the two and the absolute value. So we don't need to worry about negatives. In fact, does anybody notice anything? Okay. 54 minus 49.4, 50 minus 54.6. They're all 4.5? 4.6. Okay, so they are all 4.6. Okay. All right, well now what do I want to do with each one of these? From each one, I want to subtract 0.5 and then square it. So again, doesn't matter if that difference turns out to be negative, the square will make it positive. Yes, ma'am? Okay. So somebody help me out. It's going to be the same every time. So what's 4.6 minus 0.5 squared? Okay. Okay, so I hear very small. I got 16.81. Is that what you folks are getting? Okay. So every one of these are the same. 16.81, 16.81. Jacob, did you say totally? Totally. 16.81. Okay. All right, now what I want you to do is kind of take this to the end yourself. All right. Each of these square differences, you're going to go ahead and divide by its respective expected value. Okay. And then you're going to go ahead and take the sum total at the very bottom of that. Okay. So let's see if we can all come up with the same value. And just so I would have a more approximate answer, in this last column, I rounded mine to 4 decimal places. So I'll go ahead and put those up there in just a moment. Okay, so while you guys are finishing up with that, I just want to go ahead and say that this issue with having the expected values less than 5, having a degrees of freedom of 1, Yates continuity, this is not going to be tested. I'm not going to give you a quiz over this. I'm not going to test it in here, and it will not show up on the paper exams. Okay, this is only going to apply to you if you're using chi-squared on your internal assessments, and it happens to fit one of those 2 categories. It's the only way. Okay. Otherwise, you may not even need it. Okay. All right. So let's see what we got here. For the first value, I got 0.3403. Okay. Would you guys agree? Okay. Anybody help me out with the next one? 0.3079 is exactly what I got. Third one. 0.3686. And we finish up with our last one here. 0.3335. Okay, for a grand total of, I got 1.3503. This is the chi-squared calculated value I would use because my two-way table had a degree of freedom of 1. And then, of course, you would go ahead and compare it to your critical value and make your assertion based on that. Okay. Questions? Is anybody having a hard time with the chi-squared? No? Okay. Now, I just wanted to go ahead and introduce that to you. I'm showing 153. We can absolutely go back and do another problem if you'd like. I will leave that up to you. Jacob, what do you think? He's okay. Anybody else? All right, if you do change your mind or if you run into one of these situations on your internal assessments, definitely look back at your notes or come ask me a question. Just kind of figuring we can get through with this pretty quick today. I did give you something yesterday that's due Monday. What am I referring to? Okay, it's that outline. Okay, you want to fill out that document. Okay, remember complete sentences. And I am looking for what? Data. I'm looking for data. Okay, now you don't have to have done anything with the data yet. I'm not looking for the strategies. Okay, but I want to at least see the data you've collected. I want you to get going with that. Now, if you feel you have a good amount of data, you've got good data to begin with, and you want me to start looking at some of your math strategies, perfectly fine. But the highest you can get on that grade is a 90 if you don't turn in any data. Okay, the way I've set up my rubric.
Turn in data, do you just want us to attach it on like a separate sheet?
Yeah, Emmy just asked, basically what you're going to do, I would just, have that data on a separate sheet of paper. You'll just staple the two together. Okay. And remember, if you want to turn it in early, you can. I mean, you can go through the weekend, but it's due on Monday. And I think, unless anybody has any other questions, how are the internal assessments going anyway?
It's more difficult to find data than I thought.
It's more
I
difficult.
didn't research it, so I went to the library
Mm-hmm.
today.
Because, yeah, the one thing I've noticed is that a lot of people have some really good ideas. The only concern I have in a lot of cases is how do you measure certain things?
Yeah.
How do you collect data for that? So, yeah. I'm kind of curious, is there anybody out there who has started writing the paper at all? Maybe even a paragraph? So a few folks? Okay. All right. So you still have a lot of time. Jacob, you're still what?
I'm still trying to finish my other IAs.
Still trying to finish your other IAs? Okay. All right.